This group, our client is Dr. Goff, our advisor is Dr. Yagodzinski, and we are Team Titrans. I'm Chad Burgess, I'm the design lead.
I'm Dan Meadow, and I'm user interface and user experience.
I'm Andrew Nelson, I'm the documentation lead.
And I'm Robert Yard, and I'm the team lead.
For our presentation, we will be going over a quick recap of before, our functional and non-functional requirements, prototype demonstration, quality assurance and project risks, conclusion, and quick Q&A. Titration is the process of adding an acid or a base of a known concentration to an unknown concentration of an acid or base. We were using an agile process doing this, which would include our daily stand-ups and weekly advisor and client meetings. The reason why we're doing this is because titration is very difficult for some students to understand. There's a lot of math involved, a lot of equations, so this will help simplify it for them. Email is very unreliable, and it's hard just to do any equations through email. In office hours, obviously Dr. Goff can't give 2 hours to each student just for titration. Some of our functional requirements are the user can select chemicals for the titration. It'll display a graph that has labeled numeric outputs. It can also expand and contract the graph. This app will also show a step-by-step solution, including all the equations and the data points the users added. You can add more titrant if needed. The program can also find the solution for a user. You can export the data, and it'll also have a help menu for the user. Our non-functional requirements will have the computation done solely on the device, so in case you don't have internet, you can still do it. It won't show irrelevant information, so if you select an acid, you can't titrate with another acid. It's got to be an acid or a base, and vice versa. Able to do scientific notation, for example, 10 to the power of 4 or 5. It will also implement tooltips, speech to text, and natural language selection.
So when the application is first started, this is our opening screen. What I'm going to do is set up how a student would most likely use this. They will perform the titration themselves by hand first and get all the necessary information they need and perform their equations, and then use this to test it against their results. So let's say they're using hydrochloric acid to titrate with, and it has a molarity of, let's say 0.2. Well, that's 1. And then since the titrant is an acid, we need to make sure that we're using an aniline for a base. This is potassium hydroxide. And we're going to, the concentration of this aniline begins unknown to the student until after they perform their equations, and then they'll get this and we'll leave that as a 0.4 molarity. And then the final thing they input is the amount that they started off with, the initial volume of their aniline, so that they can perform these calculations. And then, as you can see, it pulled up a graph for us to see. When we first had our demonstration last quarter, we had this populate with dummy graphs, but now you'll be able to see we are able to actually pinpoint these and perform the calculations. When a student uses this, most likely they're going to start with very small amounts, because if you add too much at a time, the calculations, you can miss important value points. So, as you can see, every time I tap add titrant, a new dot is created. And you can see as the pH is slowly changing. This is going to take a little while, so I'm going to change the value a little bit so you can see a little better. And then we can continue adding. Sorry. Pretty much I started with too great of a volume for the aniline, and that's why this is going to take a little longer than it should have. Yeah. And as you can see, the pH drops. And as you can see, since I'm adding too much at a time, it misses its equivalence point, which is a pH of 7, which means that the acid and base have neutralized each other and become basically hard. Normally there will be a point right here where it can show that, but since I'm adding too much at a time, it skips that point because of how the equations work. But say a student wants to go back and they need to look at a specific point, and they're values. We can scroll through any point and expand the graph to see individual points, and we'll have a tooltip right here that pops up showing how much the exact volume of it's currently at and the current pH value. And once done, they can clear, go back to the home screen, and perform a different one. That's how a student would use this. Now Chad's going to explain a little bit more about the features we use.
So one of the things we wanted to really do is make our program user-friendly, right? We wanted to have a simple and, if I dare say, elegant layout. We programmed into the application acids and bases that you'd be using. Currently we have strong acids and strong bases. You're able to select those. You're able to see what the next field is. It's clearly labeled on the right. It's the concentration of this titration. We'll give it a 1. We already have a base up in the first one. We're going to add an acid to it. Let's do let's add a 1 there. And then we'll start out with a volume of 100 milliliters. But first I want to show you what happens if you don't add anything. So you begin titration normally, but since there's no entry in this field, we actually have it checking so that you can't create an error and crash the program. That's one of the things we've implemented so far. So let's go ahead and actually add some numbers here and begin titration. We're going to add 100 at a time. And see, now you have right at 7, we have a tooltip, we have the milliliters it took to get there, and we have the pH value. And again, you can expand, contract, and you can keep adding titrate and get the graph going up. Another thing we wanted to do on this page was, again, check to see if there was nothing entered in the field that said milliliters of solution to add. Try and add titrate, and nothing happens. We also added a clear function, allows you to go back. One thing that we really wanted to keep steady was the user experience between devices. So I'm going to go ahead and get it out on a different device here. And we have it running. Same layout, same experience between devices. You still get the idea that you can't add anything until you have all your fields set up. Let's go ahead and add that again. Change this to an acid or to a base, and begin titration. Now we're going down. And there you go. That's the user interface.
There are many project risks when trying to understand a project that is developed over a long time. The two biggest risks specific to our project was the lack of knowledge of Android development and the lack of knowledge of titration. The way we worked around the lack of knowledge of Android development was working with pair programming, and we actually had to deal with saving data and how to pass that through different activities, which was pretty challenging. And the way we worked with the knowledge of titration was getting help from Kevin, who's actually a student here, who's in chemistry, and Dr. Gott, who's actually our client, and he helped us with all the equations. Every project has to deal with incomplete or missing requirements, bad planning, and unexpected problems. With incomplete, missing requirements, and bad planning, we actually held group and client meetings every week to make sure we were staying up to date on everything. And we wanted to make sure we were getting everything done on time. Lastly, unexpected problems in our project. We actually lost a team member, so there used to be 5 of us. And to remedy this, we actually implemented pair programming. But we actually did this right after we lost our teammate because it was a lot easier to have pairs with an even number. Quality assurance. We had coding standards, which was well-commented code, which made it easier to understand. And then we also had pair programming to keep each other on task and help with coding each other. And lastly, we had open brackets on the next line, which actually helps the readability of the code, we think, and it's easier for each of us to develop for the same class. So far, we've used usability testing and validation. Our usability testing was working with the device and making sure that it did what we actually wanted it to do, and it would handle unexpected inputs. For validation, we actually had algorithm testing, and the way we did this was with checking the notes of Dr. Gott, because he gave us handwritten notes of different types of things being titrated.
So where do we go from here? The first thing we're going to do is we're going to keep learning. We realize that we still have knowledge to gain about Android and the platform in general. And that's kind of been seen through our pair program. We each bring something to the table, and a lot of times it's not complete. We have to do a lot of research. The next thing we're going to do in terms of research is actually figure out how to publish this on the Play Store. We know that that's kind of far off, but we also think it's going to take a lot of time. And that leads on to finishing our requirements. And the last thing that we really need to learn how to do is to minimize the risks going forward. We did lose a member, and what we really want to do is ensure that the problems we've had in the past don't continue being problems in the future. But I do think that all of us are hopeful that we will get this done and come up with a very quality product in the end. Thank you.
Any questions?
So, with the learning titration thing, obviously that was pretty hard. I mean, if chemistry students struggle with it, computer science students are obviously going to struggle with it a lot more. So I'm just curious, did you run into a lot of roadblocks, with development, just because, I don't understand, what we're supposed to do, or, it's kind of hard to understand the requirements?
Yeah, pretty much Dr. Gott has been very helpful in that. Kevin, the student we've been dealing with, he's created an online version of what we're doing.
Mm-hmm.
And through him, we've talked about the equations he's done and any problems he's had. But he gave us some equations that weren't actually working properly. So in dealing with Dr. Gott, I spent 3 or 4 meetings with him just going through multiple accounts of titration, going through the equations, and I've just slowly learned it myself so I can actually understand what was going on.
I see.
There's definitely something lost in the translation, I guess you could say, between chemistry and computer science.
Yeah.
And actually translating that is definitely
Yeah.
a challenge.
Yeah.
So, what happens if the user selects 2 acids or 2 bases?
Currently, we do not have that function checking working. We spent today working on it quite a bit and didn't quite finish. But the idea is that a new fragment will pop up and it'll say, hey, you selected 2 bases. We're not going to allow you to begin this titration. And that fragment will also pop up if you don't have a field for the milliliters or if you don't have a concentration setting yet. It's just a simple implementation of starting a new fragment. We just haven't quite gotten there.
On top of that, Dr. Gott has actually mentioned to us about acid-to-acid titration or base-to-base titration. It does exist and it can be done, but it's not something college students will most likely be doing, and that's what he wants us for, is the college students, so it's not something he actually wants us to implement or learn how to do.
So you're saying because base-to-base and acid-to-acid titration do exist, you're not going to have this?
No, he doesn't want us to because it's for college students, and most likely the college students who are using this, he said, won't be using it. He doesn't want us to be concerned with it. He has more important features he'd like us to look into first.
We just haven't quite gotten the check done yet.
Okay, so just so I'm clear, it will tell you, so if the student selects 2 bases, it will register as an error?
Yes.
Okay.
It doesn't do it right now, but it will.
So, okay, so it was acid to acid and base to base. Is that just too complex for college students or something?
Pretty much.
Yeah, well, that and it also has there's different. Right now we have strong acids and strong bases, which is it's a very near to 1-to-1 relationship. But with weak acids, they're not as strong and they don't dissociate as fast. So there's a lot more, calculation required in that. A lot more, second and third degree, calculations.
Anything else?
Thank you.